Alright, here's the bell work. I got the 8 parts right there, and should be able to do good. So there's our answers. Number 8 may have been a little different, but it's still doable, I think. And oh, well, yeah, we can show the graphs on these other ones. Like number 2, graph the inequality from number 1 on the number line. So if we kind of went into that, I don't know, I'm going to say 30 is right here. And then 31 would be to its right, and 29 to its left, like this. Which I understand is kind of small, but in any case, it's an open circle at 30, because it doesn't actually equal 30. Like this. And this one eats the x, so it goes to the right. Which, the same conditions will apply for 4 and 5. So I'll say, this is -7 right there. We'll put -8 over here. I guess -6 over here, something like that. So open circle, this one eats the x, boom, goes to the right. And then this next one, we got 6, 7, and I guess we'll say 8 right there. Whoops, that should be 5 rather. There we go. And this one, since it's equal to 6, it could be equal to 6. We'll put a closed circle at 6, and this one eats this. It does not eat the x. So this one goes to the left. It really is that simple. Alright, so we're going to be solving inequality. So there's our objective. I can solve inequalities. Take 30 seconds to copy this down, please. Alright, an inequality is a mathematical sentence that compares quantities. Yeah, it's true. I mean, you could look at any two quantities. Something like, I don't know, even negative values like -7, and you could compare it to +4. Okay, two very common values, I guess. Well, 4 is, I guess. And then would say -7, and this would read as, we know -7 is less than 4, but again, we put this less than symbol between so that we don't actually have to write the words for that. So we can communicate this, which is very nice, very quickly. But again, if we were to compare this a little differently with, let's say 4, we'll compare it with, I don't know, 3. See, now, this would still be true. 3 is still less than 4, that's a true statement. But if I suddenly change 3 to 3 plus 1 like this, now it's a false statement because 3 plus 1 actually does equal 4. So 3 plus 1 is not less than 4, it's equal to 4. So if we change this symbol just a little bit, kind of like what we talked about last time, to an equal, now it's less than or equal to, so even though it's not less than, it is equal to, so it meets one of the two conditions, which would then make this a true statement. Okay, so we're just comparing these two values or expressions. And it could face the other way, just like we said in the bell work, right? If we switch this and we said we're going to compare 4 with 3 plus 1 this way, like this, 3 plus 1. This reads different, but it means exactly the same thing. Now we say that 4 is greater than or equal to 3 plus 1. And again, 4 is not greater than 3 plus 1, but it is equal to, which is why this is still true. Alright, so here's the 4 symbols in the table. And it's some good information, I mean, these are the top ones on these, in this table, is kind of the general statements for these. But they can be said in other ways. I don't think we see these too much in this unit, but this less than, you could say it's fewer than, or greater than could also be said it is more than or exceeds, or less than or equal to is no more than or is at most, and then greater than or equal to is no less than or is at least, something like these. Okay. So again, we can replace those types of words, and instead of having to write them out completely with words and letters, we can use these mathematical symbols, which I think is pretty convenient. And there's a lot of math symbols out there that we can use to actually simplify sentences, like word sentences. And eventually, it will look like it's a completely different language, which I guess you could say it is. Although it's not super consistent throughout countries. Like people say it is, math is a universal language. That's garbage. Practice translating sentences into inequalities. Bob's earnings at $10 per hour are no more than $150. Number 2, a price decreased by $5 is now less than $80. So Bob's earning at $10 per hour, no more than $150. We do have an unknown in this one. It says $10 per hour. Like I can't compare directly a rate with just a regular quantity like dollars, because a rate has two different quantities, right? Dollars and hours. So I need to find a way to rectify that, and to do that I'd say, well, X would be the number of hours that I guess Bob's working, I guess. Number of hours right here. So Bob's earnings at $10 per hour, so that's $10 for each hour, so we'd multiply that by the number of hours, and then we would compare that with 150. Now it says they are no more than 150, which means it could equal 150. Which is kind of the first thing I look for when I do these. Not that you have to, but it's the first thing I look for is could it be equal to in translating this? And this one is yes, it could equal 150. Bob could earn 150, but it couldn't be more than that, which means that whatever he earns, it needs to be, whoops, I did that the wrong way. It needs to be less than the 150. So it could be less than, but it could be equal to, and that would be fine. So that would be the statement. Of course, you could solve it and say, well, the most hours you could work is 15. Let's go to the next one. A price decreased by $5 is now less than $80. So X is the price, whatever the price is. You can say the price if you'd like, but I'm just going to put price. So what do we got? We got the price. It's decreased by $5, so we'd subtract 5 right there, right? Decreased by 5. Now this is less than 80, so we know we're comparing with $80, and that's a direct statement. It's just less than. So X minus 5 is less than 80 would be the mathematical statement with an inequality. And yeah, then you could solve this and say, well, the price was less than $85 if you solve this. All right, for the given value, state whether each inequality is true or false. Now this is what you would do after you've solved it. Checking for truthfulness or falsefulness, which you've done before, right? Like we've checked for truthfulness or falsefulness, but with equations, right? So we know, like number 3, you could solve that, but this one, it gives us an S value, right? So I take that S value and I replace it with this 14 over here. So I'm going to drop that, make it 14. So now it's 14 minus 7, which is less than 5. And 14 minus 7, that's 7, right? That's 7. And then we have to ask ourselves, self, is 7 less than 5? And the answer to that is no, which makes this false. Yeah, so this one is false right here. I thought maybe we should put no, but this one's false. All right, 4 and 5, this is kind of what we're looking at because they are they're similar, but they're also different on this. So let's go to 4. And again, we're replacing the K value with 7 right there, right? So I go in, I replace the K with 7 right here. That's good. All right, so K equals 7, so I'm going to replace that K right there as a 7. And then I have 5 times 7, which is greater than 35. And you know what? I'm actually going to put a question mark over the inequality just because we don't know if it's true or false. So I would actually do that. I'd do 5 times 7, which is 35. And we're comparing it with 35 as the purple 35, which is supposed to be greater than this black 35. And is 35 greater than 35? The answer to that is no, which makes this one also false. Right up in here. Well, what about this next one? What about the 5 right here, like this? Same idea. We're going to replace the Z. I don't know why there's double equal right there. It's just equal. Z equals 7. So I replace Z with 7 right there, which makes this 5 times 7. And again, is this greater than or equal to 35? That's more of a question mark, because we're not sure if it is or not. 5 times 7 is 35. And this is where it changes, right, between this one and the last one, which we can look at. Is 35 greater than 35? No. By itself, that's false. But is it equal to 35? Yes, it is, which makes this full inequality a true statement now. It seems like we talked about this last time. When you're graphing inequalities, right, and you have just the regular less than or greater than symbols, you use open circles for those graphs. If suddenly you got less than, well, I guess this one's greater than or equal to, and then this one's less than or equal to, then they close that circle, okay? So like if you looked at the number line like this, And if you're doing this by hand, you should always have three numbers. That's part 2 right there. So let's give ourselves an inequality. X is less than. I'm going to do this a little different. X is, and we'll do this, we'll compare it with, I'm going to do -2 like this. So you always put that value that you're comparing x with directly in the middle. So in this case, right, -2. Now to the left of -2, and I did negatives on purpose, is a bigger negative, which is, of course, -3. And then to the right is the lower negative, -1. So from here, you'd say, you'd look first to put the open or closed circle, right? And this one I've got equal part on this, which means it's a closed circle. So I'd go in there, I'd put a closed circle at -2, and then A and B there just tell us which way the line goes from the circle, which in this case is at -2. Now it says if the inequality eats the letter, then the line goes to the right. If the inequality does not eat the letter, then the line goes to the left. And this one does not eat the letter, which means that it goes to the left. Boom. And that would be graphing these inequalities like this. Now, of course, we're going to be solving them as well as graphing them. So it's not going to start out most of the time with just -2 is greater than or equal to x. You'd have to be able to solve the inequality and narrow it down until you compare just an x with a number like we have seen right there. So a little practice on this, right? We got 4 different inequalities, but see how it's comparing x with 4. So number 1, right here, let's go to number 1. It says x is less than 4. Now it should have 3 values on that, right? So it'd be 3, 4, 5 like this, actually for all of them. So at 4, since it's x is less than 4, it's just less than, which means 4 by itself, if I replaced x with 4, would make it a false statement. So I have an open circle at 4. And then this one is not eating the x, which means the line goes to the left. Something like this. Okay? And we can do number 2 as well. X now is greater than 4. So again, at 4, make it show up. Well, we should have 3 values, right? 3, 4, and 5, like this. And this one is open, again, because 4, if I replace the x with 4, it would still be false. But now it's eating the x, which makes this line goes to the right. And we'll put the 3 values on each of these. And this first one, number 4, I don't know what happened to 3, but x is less than or equal to 4. So it's now equal to 4, so if I replace the x with 4, it would be true, which means I need to close in that circle. And that one does not eat the x, which means the line would go to the left. Same with number 5. This one is greater than or equal to 4. So again, to show that it's equal to 4, or if I replace the x with 4, would be true. I close in that circle, and now this one's eating the x, which means the line goes to the right. So again, all that stuff is based on the slide we saw previous to this one. And so the reason why we want 3 values on these number lines is because, just like I showed with the negatives, we need to know that you understand that with positive values, they get bigger as we go to the right. I mean, it's true for negatives, but like we saw on the last slide, right? If you have a negative right here, like this, there was -4, you'd have -5, and then to the right is -3. Some students get that confused when they're writing their own number lines, and so we need to make sure you understand what numbers are to the left of the value and what numbers are, like this one, to the right. This is an inequality right here. Now, inequalities are solved, especially with one variable, I should mention. Inequalities are solved exactly the same way that we solve equalities, with one exception. There's only one exception, and we won't see it in this problem, okay? So what this means is we're going to treat this like we would just a regular equation, meaning that nothing's going to change that inequality. Well, I mean, some things could change it, but the way we're going to do it isn't going to. So right here, just by solving equations, we would look, is there any distribution? There is none. Is there any combining like terms? No. So then we're looking to isolate the x's, which means I don't want that -8 right there. I want to zero that out. So I add 8 right there. And again, the principle of equality would mean if we do it to one side, we must do it to the other side as well. So that will zero out. We'll drop the 5x. And again, we have the same symbol right there, greater than. But now we got -23 plus 8, which is -15. So nothing new to this point, right? It's just solving equations using principles of equality. This continues because we don't want 5x's, we want 1x. So how do I change that coefficient of x to a 1? Divide it by itself. But if I do it to one side, I must do it to the other side. That becomes a phantom 1. X now is greater than negative 15 divided by 5, which is negative 3. Now, we need to consider what we talked about in the last class, the last lesson, is how many solutions are there to this original inequality, and there's an infinite number of solutions. This inequality right here demonstrates all of those solutions. Now again, we should ask, well, what if I replaced x with negative 3? Would that be true? No, because negative 3 is not actually greater than negative 3. But anything to the right of negative 3 on the number line would make this true. So even though it didn't ask us to graph this, let's go and graph it because graphing is so fun. So we're going to use 3 values since we're doing this by hand. I got negative 3 in the middle. And again, to the left is a smaller value, which for negatives means it's kind of a bigger negative. And to the right is a bigger value, so it's a negative 2 right there. So I'm comparing x directly with negative 3, or this is where the inequality changes from truthfulness to falsefulness. And if I replace negative 3 with the x, then it would be false. So I have an open circle there. This one eats the x, so the line goes to the right. Boom. So again, this means that any values to the right of negative 3, if I replace the x with any of these values on the number line, to the right of negative 3, this original inequality would have been a true statement. And that's the difference between these inequalities and equalities, is now we have an infinite number of solutions, but they're very specific solutions. Any value greater than negative 3 would make it true. Solve this inequality and we'll graph the solution set on a number line. That's our favorite, because we've been doing this already. So, principles of equality. Yeah, even with the fraction, that shouldn't be too bad. So, no distribution, no combining like terms, but I need to isolate that x over 2. So I'm going to get rid of that plus 9 by subtracting 9. But principle of equality means if I do it to one side, I got to do the other side. So I will drop this x over 2, which by the way is just x divided by 2. And again, nothing like that will change the inequality. And then 5 minus 9, and that's zeroed out by the way. 5 minus 9 is negative 4. That's pretty good. So from here, now that I got x divided by 2, now I'll do the multiply by 2. But again, if I do it to one side, I got to do the other side. What happens is that x divided by 2, that becomes a phantom 1. So I'm crossing those out, but it's not just I'm saying that they're canceling out. It becomes a phantom 1. So now x is greater than negative 4 times 2, which is negative 8. Boom, there we go. So that solves the inequality because I now have an x directly related to just some value. And now we can go back to the equation right here. So, the graph. I need 3 values, and we're looking at negative 8, and again, to the left would be a bigger negative, negative 9. To the right is a smaller negative, negative 7. Now, x is greater than or equal to negative 8, which means if I replaced x with negative 8, it would be true, which means I need a closed circle right up in here. And this one is eating the x. Therefore, the line will go to the right, like this. So there's the graph. And again, just to explain this, because there are infinite solutions, generally speaking, for inequalities, that means that any value to the right of negative 8 and also negative 8 would make the original inequality a true statement. Since we haven't seen the exception yet, I assume it's coming up, but we need to see that it'll be very crucial in solving these inequalities. All right, solve this one, and I did change that a little bit. Negative 2x plus 8 is greater than 24. Graph the solution on the number line provided. Thank you. Okay, well, let's rewrite this so that we can solve it. So negative 2x plus 8 is greater than 24. Now, if we had kept this as a positive 2x, by the way, like it was before, nothing would change. But we want to see this exception, this exceptional rule when applying the principles of equality, which will change how these solve, okay? Now, the first step, well, generally we should be looking for distribution, right? There is none. And there's no combining like terms either, so we're not going to worry about that. But we do need to isolate those x's first. And isolating the x's won't change anything in terms of principles of equality, okay? So I would just subtract 8 from both sides on this one. Just like this. To zero that out. Now this negative 2x drops. It's still greater than 24 minus 8 though, which is 16. There we go. Now the exceptional thing on this one, and you guys saw because I made this problem up, is the negative coefficient right here, negative 2 coefficient of x. Since this coefficient is a negative, when I apply this division principle of equality, divide this side by negative 2 to make that coefficient a phantom positive 1. But if I divide the other side by negative 2 right here, then I get x. But because we looked at and divided both sides by negative, it's going to flip that inequality. So now it's x is less than negative 8. So when we go to the the graph up here, we got negative 8. Seems like we just did this one, didn't we? Negative 9 and negative 7. It's an open circle because it's not equal to negative 8. At negative 8 on the number line. And this one does not eat the x, which means the line goes to the left. Alright, so this one is a nice quickie. We're going to solve it and graph it. So first up, right, we'd be saying I want a 1w, not a negative 3 w's. So I divide both sides by negative 3. And that gives us the phantom 1. So w compared now with 13, negative 39 divided by negative 3. But once again, since we used division, property of equality, with negatives, we need to flip that inequality. So now w is greater than positive 13. So now that we know that, we can make the graph. And in the middle, I'll put 13. To the right would be 14. And then to the left would be 12. And I know some of you guys are like, well, that's not an equal spacing right there. I really did try, though. Okay, so as long as you're trying, I mean, here's what we would not want to see. You know what I'm saying? Like, if you put your 12 right here, be like, okay, like, I may actually lose sleep if I see that right there. So try to make it at least, you know, give it a good go when you put that over there. That looks pretty close. All right. W is greater than 13, so it's not equal to, which means I need an open circle. And it's eating the w, which means the line goes to the right. Done. Because this is a fractional answer, when I go to graph this thing, again, I'll still put 3 values with 27/10 right in the middle. Okay. But to the left of 27/10, I'm not worried about simplifying these, specifically so that I know that I'm comparing the correct values. To the left, I'd put 26/10. Some students are like, well, I need to figure out what two numbers that's between, which is true. Like you could use, what is that, 2 and 3? But if I just continue with the fractions like this with the same denominator, then it's a pretty direct comparison. So to the right of that would be 28/10 like this. So at 27/10, it could equal k, so I would again put a closed circle there. And that one eats the k, therefore this line goes to the right. I missed a spot right there. So that is the graph. That is the inequality. And we're done. In fact, there's another way to write the answers to these. But again, you'll cover that in the next grade. Okay? Alright, solve the inequality, graph the solution on the number line, and then give the answer in inequality notation. Well, yeah, and then we're going to graph it too. So let's look closer. This 3x plus 4 is greater than or equal to 16. Again, I look. Is there any distribution? Nope. Is there any combining like terms? Nope. So then I would look to use principles of equality to isolate my x, the 3x's specifically. So I'd say that plus 4, it's got to go so that my x's are isolated, all 3 of them. And that means I'm going to have to zero out that plus 4 or positive 4. So that's going to make that a 0. So again, this principle of equality will not change, and it will never change the way that this inequality is going to flow. And I'm going to drop my 3x. So 3x is now greater than or equal to 16 minus 4 is 12. Then I would divide both sides, just again like I would with an equality, by the coefficient of x, making that a phantom 1x. X now is greater than or equal to 12 divided by 3 is 4. So now I have a straight x compared with just a 4. No other operations needed, so I can now graph this thing, okay? So I'd say right in the middle, again, I put the number I'm comparing x with 4. To the right, I'll put a 5er, and to the left is a 3. And again, this one is equal to the 4 right there, so I'm going to make that a closed circle at 4. So in other words, again, 4 makes that the original inequality a true statement. And this one also is eating the x, therefore this line goes to the right. Okay? Now I showed it like this. Some students are like, I'm going to show it like this. Some students put it right on the line. It's up to you. It all means the same thing. All right. Well, yeah, I know we've got a lot of practice with it, but let's look at this one, okay? So again, no distribution, no combining like terms. Let's zero that positive 8 out there by subtracting 8. But if I do it to one side, I got to do it to both sides, so that's going to zero that out. Drop the 7x, which is now greater than or equal to negative 34 minus 8 is a negative 42 right there. Oh, that's going to work out really nice. Then I divide both sides by the coefficient of x. That's a 7. That's a now phantom 1, x, which is greater than or equal to, this is negative 6 right there. Okay, so we're comparing this with the negative. Still eating the x, a lot of eating the x's. But here, I'm going to say we got the 3 values, right? We got negative 6. I could have done a better job on my spacing on this, but fine. I'll try to fix it. There's negative 5. Well, on this number line at negative 6, I can see x could equal negative 6, so I got a closed circle there. And this one, eating the x, boom. We'll make this line go to the right. And we're done. Let's do this one just because it has some distribution in it. Distribution is so fun. So, we do need to distribute that 4 into that set of parentheses first. And once we solve this, we'll graph it, right? So we'll distribute the 4. 4 groups of 1x, that's 1x. 4 groups of 1x's would be 4x's. 4 groups of negative 2 would be negative 8. So now this is less than 3x plus 5. And again, we won't see the rule on this one. But if I were to continue with this problem, I'd say I want my x's on the left and the numbers on the right, which means that negative 8 term is on the wrong side of the inequality. So I'd have to zero it out by adding 8 to both sides. So that's going to zero that out. I'll drop my 4x, which is now less than, I'll drop the 3x too. 5 plus 8, boom, positive 13. But now that black 3x is on the wrong side, so I'd have to zero that out by subtracting 3x. But if I do it to one side, I have to the other side. So that does zero that out. 4x's minus 3x's is 1x's, which is now less than, drop that 13 right there. And just make that a phantom 1, and we're done with the inequality part. So then, we'll go to the graph and put this down on the graph. With 3 values, 1, 2, 3. So right in the middle I got 13, to the left is 12, to the right is 14. And this one is x is less than 13. Since it can't equal 13, I'd have an open circle at 13. And this one does not eat the x, therefore this line goes now to the left. If we go back to the original, right, let's say we replace this x with 13 up here at the top. Well, 13 minus 2 is 11. 11 times 4 is 44, right? Well, 3 times 13 is 39er, and then plus 5 right there would be 44. 44 is not less than 44, which is a false statement, right? Which, again, is why that is an open circle. So negative 6x minus 10 is less than or equal to 8. But we have the rule on this one, even though we don't know what it is yet. But for this one, same principles of equality. I need to isolate my x's, and that's when we will see the rule, okay? The extra rule with the principles of equality stuff. So negative 10 plus 10. I did it to both sides, though, the principle of equality. To zero that out, and I drop my negative 6x, okay, which is still less than or equal to 8 plus 10 is 18. Now, once we get to this point, no matter how much work we've done before it, once we get our x's isolated, and we're comparing it with a number like this, then we have to use either a multiplication or division property of equality, which in this case would be dividing both sides by negative 6, like this. Okay. Now this is exceptional because we haven't multiplied or divided both sides by negative yet, and this is a negative 6. Since we're dividing in this case, but it could be multiplication, if you ever multiply or divide both sides by a negative, so if you use the principles of equality of multiplication or division with negatives, then you have to flip the inequality. Okay, so that now becomes that's a 1x, right there, phantom 1. And 18 divided by negative 6 is negative 3. So that is the rule, that's the extra rule that we have to consider with inequalities, is when you ever multiply or divide both sides by a negative, then you have to flip that inequality. Another way to look at it is if your coefficient in the end here is a negative, then you're still going to have to flip that inequality. Okay, and that has to do with negatives, particularly with multiplication or division with negatives. Generally produces opposites, and it's the same with inequalities. Okay, whenever we use these types of rules, multiplication or division with negatives, it gives us the opposite inequality, which where this one before was less than or equal to now becomes greater than or equal to. Yeah, so notice like at the top there where we use the addition principle of equality, addition and subtraction principles of equality will never affect your inequality. It's just strictly equality, so it won't affect that. But it's the multiplication and division we have to worry about. Yep. All right, now that we got that, let's put this on the graph. Negative 3, negative 4, and negative 2. And this is x is greater than or equal to negative 3. So again, we got a closed circle, which also means that negative 3 would make the original inequality true, and it would. It's very nice. But this one eats the x, which means that the line would go to the right. And there's the graph. So let's go ahead and solve this inequality. And yeah, this one has some distribution, so I need to focus on that first. And this first distribution, that's a phantom negative 1 right there. So I need to distribute that into the parentheses. So negative 1 groups of 7x would be negative 7x's. And negative 1 group of negative 6 would then make that positive 6. But there's also another distribution with this 4 over here, right? So 4 groups of 3x would be 12x's. And 4 groups of negative 4 would be negative 16. So the rest of this inequality, nothing changes with distribution. Or it shouldn't. So now that we have this, then we would look for combining any like terms, which there are some, negative 16 and negative 2, which is negative 18. So now that's fully simplified as far as we can with distribution and combining like terms. But now we got negative 7x plus 6 is less than or equal to 12x minus 18. Now we're going to solve this pretty much the same way we would a regular equation, and generally speaking, most of you guys like the x's on the left and the numbers on the right. So I'm going to apply principles of equality. I'm going to apply 2 at the same time, by the way, by getting rid of that plus 6, by subtracting 6 from both sides. And yeah, remember to focus on keeping those like terms combined. And then we got 12x on the wrong side, so I'm going to zero that out as well, so subtract 12x. So here's what happens. This positive 6 zeroes out, and same with the 12x right there zeroes out. I got negative 7x minus 12x, which is negative 19x's. And again, that's the subtraction principle of equality used twice. So subtraction principle of equality or addition will not affect the way that the inequality faces. So we got negative 18 minus 6, which is negative 24. And then finally, to solve this one, we would divide both sides by negative 19. So then x, and yeah, because that's a negative, then we just divided both sides by, right, with the negative 19. That's going to flip this inequality. So now it's x is greater than or equal to, I'm going to write this as just 24/19. That's fully simplified. But how do you put a fraction on the graph? Easy. So easy. So again, in the middle, I'm going to put this 24/19 just like I have right here. And even though some of these fractions could be simplified, I'm not worried about that garbage right now. To the left would be, I would just say 23/19. It seems like there's a Monsters, Inc. reference on that, but to the right would be 25/19. like this. So at 24/19, was it 23/19? Okay, that's a closed circle because it includes 24/19 as a solution, and this one eats the x, so the line goes to the right. Done. Okay, so we'll solve and graph this one. Negative 5x plus 45 is greater than 10x plus 75. So yeah, I got to determine which side I want my x's on and which side I want my numbers on. Since we generally put the x's on the left and numbers on the right with equalities, I'm going to keep this consistent with inequalities as well. So that plus 45, I'm going to zero that out by subtracting 45. If I do it to one side, I got to do it the other side as well. Like this. Now I can do this in one step. So that 10x, which is on the number side of things, I'm going to zero that out at the same time. So I'm going to subtract 10x right there, and subtract 10x right there. If I do it to one side, I got to do it the other side, right? So negative 5x minus 10x's would be negative 15x's. Again, I just use the subtraction principle of equality twice, so it does not affect that inequality sign. And yeah, that zeroed out the 45 right there. I was going to zero out the 10x. But I have 75 minus 45, which would be 30. And then finally, I would divide both sides by negative 15, the coefficient of x. And again, we see this where we just divided both sides by this negative, which means that we're going to have to flip this inequality. So now that's a phantom 1x, which is good. That's what we wanted. X now is less than, or well, just less than. X is less than 30 divided by negative 15, which is negative 2. So now that we have that, we can go to the graph, and we'll put numbers there. I didn't give myself a lot of space there, so I'm going to put the numbers above, which is okay. And I'm comparing x with negative 2. It's less than negative 2, not equal to, so I got an open circle there. And this one does not eat the x, which means the line goes to the left. Boom. So this one's going to have some distribution and combining like terms, which is good. It's good for us to have that type of practice. So let's get it done. Let's distribute the negative 4 into the parentheses. Negative 4 times x would be negative 4x's. And then it's negative 4 times negative 7, which is positive 28. We didn't really do anything with the rest of this stuff, so we still got the plus 5 is less than 3x plus 6. So that's distribution, but I have some like terms to combine right here, the 28 and 5, right, which is 33. Positive 33 specifically. Now we got negative 4x plus 33 is less than 3x plus 6. And once again, I'm going to choose to keep my x's on the left and the numbers on the right. And yeah, we'll do this with one. We're going to do two principles of equality at the same time. Right? I'm going to zero out that plus 33, so I don't have to subtract 33. But if I do it to one side, I got to do the other side. And that will zero that out. But also, I'm going to get rid of that 3x, zero it out by subtracting 3x from both sides. Okay, so that's going to zero that out. And negative 4x's minus 3x's would be negative 7x's, which is less than 6 minus 33, which is negative 27. Yep. And then, the last thing here is to divide both sides by the coefficient of x, which is negative 7. And once again, we see that we're dividing both sides by a negative, which means we're going to have to flip the inequality. And that gives us x is greater than, yeah, that'd be 27/7 right there, positive, by the way. So now we're ready to put this on the graph. So right in the middle, I would have the 27/7. To the left, well, I'd make that 26/7. And to the right, 28/7. So at 27/7, x is greater than that, not equal to, so I got an open circle there. Like this. This one is eating the x, so the line goes to the right. Boom. So in elementary school, sometimes they say some things that we have to fix in, 7th and 8th grade math. And we like our elementary teachers, just sometimes they're a little misled, especially with the math. Like, I don't care if they're misled about English or science, because I don't really care about that crap. But the math I do care about, because we're in a math class. So, sometimes, and if you guys have heard of this before, I'm telling you right now, don't do it. Because they'll say something like this. When you're graphing the inequalities, see how this inequality, I mean it's less than inequality, but it points to the left? Oh, that's an open circle, and then it tells you which way the line goes. All right, this is only true sometimes. And it will be true every time as long as you always keep the x's on the left. But if you were to write an inequality with an x on the right, like let's say we're comparing with 7, right? Like this. See how it's eating the x? So in actuality, this line would not go to the left, it would go to the right. Okay? So this is going back to one of the first slides we saw. If the inequality eats the x, the line goes to the right. If it does not eat the x, then it goes to the left. Okay? So you're better off thinking about it that way because sometimes it's more convenient to keep the x on the right. The other thing we need to talk about is the eating part. Because, remember, and this, again, elementary teachers, we love them, just, man. So, you'd say it eats the thing that's bigger, right? Like if it was cheeseburgers, you'd want to eat more cheeseburgers. Or bacon. I like the bacon one better. So, and then they do, because elementary is full of like hugs and good feelings and good vibes and stuff. And it's like, welcome to 7th grade, man. It goes away really fast, So in elementary, they were like, hey, we're so full of love, we're going to make this an alligator. And sometimes it's like a really nice alligator. You know what I'm saying? And then it's got a tail. And elementary teachers draw stuff for you guys like this. And you're like, oh, that's so cute. And then it eats the bigger of the two, right? I better not see any alligators on any papers. By the way, the teacher next year doesn't want to see alligators either. It's so immature. It's so inappropriate. It's so elementary. Don't do it in 7th or 8th grade or ever again.
Why? I want to do it now. You're making me want to do it.
No, don't. No, don't do it.
Please.
There's nothing that will ruin my day faster than you guys drawing stinking alligators for these stinking inequalities.
Can I just do it once?
Well, let me explain why. Okay, not just that it's immature, which it is. It's like, what grade are we in? What is that, 2nd grade stuff right there? Maybe kindergarten, I don't know. But elementary teachers do this and they ruin things for us because then you're like, I gotta draw alligators all the freaking time.
You're welcome, I just drew an alligator.
Well, now that we're in 7th grade, and 8th grade math stuff, we need you to step it up. And what you're going to do is you're going to put some stinging wings on this sucker, okay?
Oh, okay. Wait, can I do that?
There we go. So, and it's got 2 wings. These are bat wings, by the way. It's kind of like a chimera, you know what I'm talking about? So this is now up the game, and it's like, okay, that's, what? You're on the right track. You're doing pretty good. You put some wings on that alligator. That's not so elementary anymore. It's like you're thinking beyond. You see what I'm saying? But this is also like 8th grade stuff, so we got to step it up even more. It's like a alligator bat, like a balligator. I don't know.
Have a man riding it.
Boom. We put on another like a shark fin on this sucker, and it's like, hey, now it's like a bat, alligator, shark, a balagark. No. I think we can do better. It's like a shark, alligator, bat, a shalagat. There we go.
Wait, why is the tail not closed?
Because this is a math class. That's why the tail isn't closed. So, keep this in mind. If you're going to draw alligators, don't do it. Draw a shalagat instead. By the way, no one's seen these in actual nature, probably because you can't run from them because they're so fast. You can't really swim away from them because they swim really fast. And I don't know if you could fly, but if you could, they'd fly after you. I believe Chuck Norris has seen one, but I could be wrong about that. This one looks more happy than he should be. Now I feel better. Yeah, that good? That good? Should I put some red on his teeth? There we go. This is a math shalagat. If you guys want to take that for, I really don't care. But no alligators. So here's what we don't want to see, by the way, because here's what a couple things on this. Okay, so in elementary school, if you guys have seen this stuff before, sometimes they'll say, "Look at the way this pointed," and then on the graph, they say it goes in that same direction. But that's not always true in this grade. So don't think of it like that, please. Okay. The other thing that we need to address, because elementary teachers sometimes make this mistake as well. They'll say, look, it's eating a certain value, right? And you're like, oh yeah, it does. It's pretty good. And then they do cutesy things like give you hugs, and they'll say, look, it's like an alligator. It eats, and I don't know why it would, but it eats the bigger thing all the time. Maybe because it can't run as fast, right? So they'd say, there's your alligator right there, and
That's like pretty good.
well, no, that's the point though. Is
You could be an artist.
I just want to specify, if you guys are doing this stuff by hand, please do not draw alligators. Like, we should be way beyond that in terms of maturity.
I don't know.
What if we are?
So if you're not, then please get there soon, because if you draw any alligators on your paper, just know that I have to take points off. And here's why. Let me explain so that there's no confusion. All right. Not only because it's not very mature, it's very elementary-ish. You know what I'm saying? What we expect, is for you guys should be going the extra mile at this point. You should like give the alligator some wings. You know what I'm saying?
It's a dragon. It's a dragon.
Now, that's not a dragon, really. It's like a
Instead of a griffin.
it's like a mix between a bat and an alligator. It'd be like what do they call them? Chimeras, which have to do with alchemy. I heard in some anime. But this would be considered like a bat alligator, like a balligator. But just so you guys know, this isn't far. This is not going far enough. This would be like 7th grade kind of stuff. And I know you guys are in 7th grade, but this is 8th grade math that we're doing. So I would expect you to like add an extra shark fin to that, some gills.
So like.
Now this would be like a bat, shark, alligator, alligator,
I can't
shark,
tell if you're being serious
or like
or
a
drawing stuff.
shark, alligator, bat. I'm gonna call this the shalagat, okay? The shalagats are extraordinarily dangerous. They're very fast on their feet, which is surprising. You can't really swim away from them, and if somehow you could fly, you couldn't fly because they got wings. So, as far as we know, no one's ever lived to tell about one of these in history. Maybe Chuck Norris. Okay. But yeah, I would not want to encounter one of these in nature. Not that it's natural. So yeah, it's made through alchemy. This is the shalagat. Because it's a cross, it's a chimera with a shark, an alligator, and a bat. There we go. So if for some reason you feel the need to draw alligators, please stop it and draw shalagat instead.